Hey everybody, welcome back to Christian Penguin 1990. My name is Matthew, and we are going to step away from apologetic side for now for a little bit, and we're going to start going through creation versus evolutionism. And like I said, I wanted to go through it step by step, starting with Big Bang, and then just going step by step as we go through it. So we're going to go over the Big Bang, and of course I have my notebook. I always take notes and keep an outline because it helps me just keep everything in order instead of just rambling on and on, which some of y'all think I am rambling, but so anyway, so Big Bang or Big Dud is what I decided to entitle this. I know others probably use the same title, but that's just why the best way I can explain it. But we need to understand that the whole thing started with George. Sorry, I'm bad with names too. That's another reason why I took notes. Lemaitre, Lemaitre, in 1927, and then afterwards, it wasn't until Gamow, R.A. Alpher, and R. Herman made up the basic model in 1948. And that model at that time was that nothing was in the beginning, and then all of a sudden there was an explosion, and we got everything we have today. Now, there was another one afterwards, which I forgot to write down who it was that came up with it. But the other one afterwards was that matter had always been in existence, and then a powerful gravitational force pulled it together, and then it exploded, and so on. But also, something that Gamow did with his is he made some very exacting measurements. You know what? I forgot to write down what that stood for. But one of them was for density, 10 to the 94th power of, and I'm sorry, I forgot. I think it's gamma meters. I'm not sure. I can't remember what it was. GM over centimeters squared. I forgot to write down what that was. It's been a while. I'm sorry. I think it was gamma meters. And the temperature that it reached just before it exploded was 10 to the 39th power of absolute degrees. So for density to be that dense and that hot, and then him giving exact measurements. First of all, my question would be, where did you come up with those measurements? And how did you even scientifically go about getting them, or did you just make them up? And the truth is, he made them up because at that time, well, even today, there's no way to actually guess what that was, even if the Big Bang had happened. I mean, so he was just making it up as he went. But here's some problems. Big Bang Theory is based on the theoretical extremes. In other words, looks good on paper, but can't actually happen in real life. And like I said, we'll go through that more, and you'll understand that as I go through it, as I took notes from different things and that I've read, and just overall looked at them. I'm like, okay, well, here's a question, and just overall to me just explains it. Problem number 2, nothingness cannot pack together. So if there's nothing, you can't pack nothing. In order to pack it, you have to have something, not nothing, because nothing will never come together, because nothing is nothing. Vacuums have no density. That should be self-explanatory on that one. But that one kind of goes in line with something else a little bit later. I'll get into that in a minute. There would be no ignition source. So in other words, if you have nothing, and I mean absolutely nothing, there's no chemicals to cause a chemical explosion, and there's no atoms and so on to cause a nuclear explosion. So what exploded and how did it explode? There was no ignition source to begin with. Okay, so now this one is going to slightly cover the other one. There's no talking about where it just expanded, not exploded. There's no way for it to expand. And the note I have with that is the gravity which brought it together would keep it from expanding because it's just so strong. So that's why people say, well, it had to have exploded, because if it just slowly spins for billions and billions of years, it's not going to break away from the gravity. The gravity would have to disappear completely for it to do that. And it's not going to happen if it was strong enough to bring every particle in the entire universe together in one little point. Well, it's over billions of years. It's not going to just release it. Okay, so something would have to cause the gravity to disappear first. And it just ain't going to happen. Nothingness cannot produce heat. And an empty vacuum in the extreme cold of space can't get hot by itself. In other words, something would have to bring heat on it to make it hot. An empty void can't magically make itself into matter. In other words, nothing can't just magically pop in as something. There had to have been something there to begin with. Can't be heat without an energy source. And again, that kind of goes back to the other one where how did it explode? Well, if you don't have anything there, there's nothing there to be an ignition source, so there's no way for it to have actually had an ignition source to explode. The calculations are too exacting. Now that goes back to the density and temperature. Remember what I was saying? On many points, the calculations can't be worked out, yet in others, they are very exact. So if you can't work them out this way, then why all of a sudden over here, you can tell us how hot it was and how dense it was. You see what I'm saying? Like, so if you wanted to say, well, what was the rate that it exploded and everything ran out? And so, well, we can't tell you. Well, this is how hot it was. This is how dense it got. Well, wait a minute. How did you get those to be exact numbers, but you can't tell me how fast it expanded or exploded out and particles went out? That's what I'm saying. So in a lot of cases, there's no calculations they can give for numbers, and then there's others like the density temp, just for examples. All of a sudden, boom, here's the exact numbers. We know that's for to be so that's what I'm saying. Okay. And this will be kind of a lengthy video. Sorry. I had to take a lot of notes. Did a lot of book reading. Okay. Such an equation would have produced a whole, not a universe. And I don't know why I put equation. It's supposed to be an explosion. I'm sorry. But such an explosion would have created a whole, not a universe. Roger St. Peter in 1974 showed that it would actually possibly create a black hole instead of a universe because it would collapse on itself and all this mess. After I post the video, in the in the description below, what I'll actually do is I will go through and I will find the stuff that they pointed out, or that I've been pointing out in the video, and links so y'all can go try and read it up if you want to. Hopefully you do go do your own research and backtrack it. There's not enough antimatter in the universe. So in other words, there should have been an equal amount of antimatter along with regular matter produced at the exact same time of the Big Bang. But we don't see that. There's hardly any antimatter and a ton of regular matter. And here's the problem. Antimatter would destroy the regular matter immediately. Every time they've made the two together in a lab, they destroy one another every single time. So if a bunch of antimatter, let's say the equal amount was made, they would immediately destroy one another. So you'd never get a universe to begin with. Now we're going to focus on just the particles themselves. So this, basically what it is we're going, okay, so now we're in the particles. Let's say it exploded. Now we're going to talk about the particles themselves. So let's assume it actually happened. Bang, it happened. Now there's an explosion. The particles are going out. So now we're going to focus on the particles. Number one, there's no way to unite the particles. What's going to attract them together? They just exploded away from a big gravitational force, and that's the only gravity in the universe at that time. So what other gravity is going to pull them together? They're going in separate ways, which I'll cover in a second. No way to slow down the particles. So in order for them to come together, they would have to slow down. There's no friction in space. There's nothing to slow the particle down. It's just going to keep going and going and go. There's nothing that's going to stop it. Particles would maintain the same vector. So if one goes this way, okay, it's going to stay that vector the entire time, and it's not going to slow down because there's nothing to slow it down until it just runs out of energy. And depending on how strong the Big Bang was, it could never run out of energy. So again, there's nothing that would slow it down enough to unite it, and there's no friction to cause it to slow down. No way for it to change the direction, and that would of course go back to the fact that there's no other gravity other than the gravity that brought it together. So in order for it to come together, there would have to be a powerful gravitational force again that would bring it together. But if the only gravity you had in the beginning was what brought it together to cause the Big Bang, and there's no other gravity, then there's nothing that's going to do that either. The atomic structure can't originate. Okay, now that's talking about going to atomic level, because according to their theory, from the Big Bang we got hydrogen and helium, but if the particles are spreading out as fast as they can, there's nothing to bring them together to bring about hydrogen and helium. So you wouldn't be able to have an atomic structure either. Okay, so we're going to go from the particles now. We're going to talk about the gas clouds. That's another one. Gas molecules in space are widely separated. In other words, hydrogen and helium. Gas in space has a density so rare that it is less than the vacuum bottles in a lab. Okay, and I had to do a good amount of research to figure that one out. But a lot of scientists, creationist evolution, like they'll view that, and they've actually said that it's just so rare that we have more of it in our vacuum bottles in the lab than there is out in outer space. And to me, that's pretty fascinating. That it's just that there's just not that much of it. Hydrogen and helium wouldn't clump together. Gas pushes apart, not together. And that goes back to the Boyle's gas law. Gas will always push apart and never come together. Gas clouds become stars? Question mark. Okay, problem number one. Since gas doesn't clump, the gas could not build enough mutual gravity to bring it together. So in other words, the gas, since it doesn't do this, it actually, it'll keep separating. There's nothing that would cause it to have enough to cause a gravitational pull. Excuse me. Still trying to fight off the last bits of this cold. I apologize for that. But there's nothing to bring enough gas together to form a small ball that would have a gravitational pull to cause more to come together and create planets. There's just not enough to do it. Problem number two. Careful analysis has revealed that there is not enough matter in gas clouds to produce stars. And the reason that's brought up is for a long time people thought that these gas clouds would come together and make stars. Or, which I'll cover later, stars would explode around them and force the gas together and you have a star. So that's where that comes from. But there's not enough to form a star in the gas cloud. There's not enough time for the gas to reach the currently known expanse of the universe to form the stars. So in other words, even if there was enough, and even though there's not, with what you have today and what they commonly see as gas cloud, and today everything is a uniformitarian constant. So if everything's a constant, then what you have today is what you had back then, and there's just not enough. And with what you have today, it would actually take longer than the supposed 18 to 20 billion years ago when it happened for everything to, come about. So there's just not enough time when you do the calculation for it to even happen. I'm sorry, I'm still fighting off this cold. Okay. Problem number 4. Gas clouds in outer space expand, they don't contract. So if you have a gas cloud in outer space, what it's actually doing is just constantly expanding. It's never coming together. So that's another small problem. Luckily, it don't take much to explain that one. Okay, problem 5. The outer rim of fast-moving matter, if Big Bang was correct. I don't think I wrote that down correctly. Outer rim of fast-moving matter. Okay, I'm gonna skip that one. I think I messed it up when I wrote it down. I'm sorry. I wrote the note down. I don't even understand what the note was pertaining to. All right. Anyway, number 6. In order for the gas to produce stars, it would have to move in several directions. It would have to stop flowing outward, which we just said it doesn't. It constantly flows outward. Would have to begin moving in a circle. Okay, I think that's what it is. The rotating gas would then have to move closer together. In other words, it would have a gravitational force have to bring it together. And then it would have to go from a linear motion and change magically into angular momentum motion. So what it'd have to do is stop going outward, start coming together, and as it came together, it would have to spin. Gravitational force would have to bring the initial gas together, which is not going to because there's none to begin with unless it's already clumped together. And it doesn't clump together. So, see what I'm saying? It just constantly compounds the problems with it. So, yeah, so it's just not going to happen that way either. Okay, problem 7. A quantity of gas moving in the same direction in a frictionless space is too stable to do anything but keep moving forward. So in other words, it's just going to, like the particles, just going to keep going. Gas in outer space, which was circling a common center, would fly apart and not condense together. And like I said, that goes back to the kind of a mixture of the Boyle's gas law and the fact there's not enough gravity powerful enough to bring it together, make it clump together, make a star. There's not enough mass in the universe for the various theories of origin of matter and stars. This means I apologize for this, but I wanted to get this video out. It means that basically density is 100 times less than the amount needed for the Big Bang. So the amount of density you see everywhere, and they've gone through the calculator, there's actually 100 times less than what was needed for the Big Bang to begin with. So it can't happen that way. Hydrogen gas in space does not clump together. Harwood's research brought this to light, and this one I actually wrote down. M. Harwood, you look at Astronomical Concepts from 1973 on page 394. And by the way, he was not a creationist. He was an atheist, from what I was understanding. Novotny's research findings about gaseous dispersion also helped disprove the thing with the gas. Again, I apologize for the coughing. Stars exploding. Nuclear gaps at mass 5 and 8 make it impossible for hydrogen and helium to change into any other kind of heavy element or element, period. So in other words, that gap cannot be breached. So helium will never become hydrogen, hydrogen won't become helium, and it won't become any other element on the table. There's not enough time for it even to occur. Self-explanatory. There's no population / generation 3 stars. All you see is generation 1 and 2, or what they commonly call population 1 and 2. And that's their research. All they found is populations 1 and 2 stars. They have never found a population 3 star, to my knowledge. In all their research, that's all they found. Random explosions do not produce intricate orbits. Now that one's very direct. In other words, some random explosion is from a star here or a planet is not going to cause its moon to jump to, say, Jupiter and start orbiting Jupiter in a perfect synchronized orbit. It's going to be either running right into Jupiter, or it's going to bypass Jupiter and just keep going. So that's what that's meaning. Also, there's not enough supernova explosions. This has been covered several times. I know Kent Hovind covers it a couple of times. Billy Crone, I think, covers it in his, and a few other creationists. I posted some of their videos earlier. You can go back and look at those. But basically, the amount of supernova rings is what they can calculate to how many supernovas they had. And right now, they're calculating enough to where they're saying there's just not enough for the Big Bang 20 billion years and so on to be correct. And what they're actually finding is enough to where it's less than 10,000 years. So if you only have enough proof of supernovas that are less than 10,000 years, then that coincides with the Bible. So they're not really going to tell you that part because they don't want to lose funding for their theories. Okay. Supernovas do not throw off enough matter to make new stars. And that kind of goes back to, if you have an explosion, particles are going to keep going. Doesn't matter how much matter there is from the star or the planet exploding. It's just going to keep going, and nothing's going to stop it. There's no friction unless it hits something, and so on. Only hydrogen and helium found in gas go flowing out from supernovas. Sorry, I couldn't read my own writing. Gas are flying out from the supernova. So in other words, now you're back to the original problem that the mass 5 and 8 problem is not going to bypass that. It's not going to skip it. So it's not going to become other elements. So even if you have the explosion from a supernova, all you have is hydrogen and helium, and they're not going to jump that gap. So they're still not going to become the other element. So you still have a big problem. Okay, problem number 8. One star's explosion wouldn't produce another star. Basically what I said earlier, if a star explodes over here, just one, you're not going to get it to push gas into another to make another star. At one point, somebody said, well, if you have 20 stars explode around a gas close enough, it will push them together and you have a new star. So if you have to lose 20 to gain one, that's not really a good thing. And there's a bunch of other problems like angular conservation of angular momentum and so on, galaxies and planets spinning backwards, doing backwards orbits. I mean, there's just so many more problems we could go over, but I wanted to keep that part kind of short. Background radiation. Background radiation is actually omnidirectional. It's coming from all directions, not just one particular direction. And I know they had a debate, Ken Ham, Bill Nye, and he was talking about, you hear the background, the hissing, the background radiation and so on. And he conveniently left out the part that it comes from all directions. It's not just from a center point. Like he wants you to believe that we can pinpoint it to this one point, and that's where it all happened. No, it's from all directions. Every planet gives it off, which we'll go through in a minute. But I mean, every planet, even people, give off a certain amount of radiation. So radiation does not fit the theory because it is too weak. In other words, the radiation given off by the planets is just too weak. It just doesn't fit. There was a note in the book I was looking at. Fred Hoyle, which I don't like doing quote mining or anything, so I left the quote out. But I just said Fred Hoyle discussed it, and he even made that comment that the radiation is just too weak for it to even be used as evidence for the Big Bang. Background radiation lacks the proper spectrum. Now, in other words, it doesn't have the total light absorption spectrum. To agree with what is known as the Max Planck calculation, and that I'll put down so you can look it up later, or I'll just put it in the description. But in other words, the spectrum does not fit with his calculation, which is what helps prove the Big Bang, and it just circular reasoning thing with it. The spectrum should be far hotter than what it is. So in other words, they've calculated that, and when I say they, evolutionists and creationists alike have gone over this over and over again, which is why it's still a theory. But they've calculated that right now the temperature should be 100 degrees Kelvin. But what they've actually found is the overall temperature is 2.73 degrees Kelvin. That's a huge difference than what is needed for this background radiation, heat-wise, to be good proof for the Big Bang. Background radiation is too smooth. In other words, it's not jittery, or it's if you look at the wavelength, it's not, being too smooth means basically it's just like this, or it's a constant, like that. But instead, it's fluttery or whatever. So it's too smooth to be part of a big random explosion. Now we're going to go into the red shifts. Okay. But to cover those, need to first touch on the different versions of shifts that there are, because they won't tell you all the versions, they tell you one, which I'll do that one first. Speed redshift, or the Doppler theory, would occur if a star is moving away from us. That's the main one they focus on, because if it's moving away from us, then they can assume that a star is 3.8 billion light years away, and due to that amount of time, whatever, it possibly can lead to an old universe theory and proof of Big Bang and all that mess. The next, and here's the ones they don't really cover. Even in my science classes, they didn't cover these. They only focused on that one. I wonder why. Gravitational redshift. The gravitational effect on light rays would cause a loss of energy. And the reason that occurs is because light has weight, and anything that has weight can be affected by gravity, and gravity would cause the light as it's traveling to curve or, shoot off. So it can affect its travel and cause it to slow down, and which would take it longer for us to see it. Second order Doppler shift. In other words, a light source moving at a right angle to me, an observer, will always look red shifted. It will not be anything but red shifted. And that's what that one means. All right. Problem number four, the energy loss shift. This is that light waves could lose energy as they travel across a long distance. In other words, the longer they travel, eventually the light will dim out and just snuff out. That's basically that one. But like I said, the main one they focus on when they teach and push the Big Bang and the billions of years and so on is the first one, the speed shift, because that was the one that goes with their theory. The others don't go with their theory, so therefore they just ignore them. They don't teach them. Now, if they do teach them, great. They need to teach every single part of it. In my opinion, they need to go through it and be like, well, here's our side. Here's what the creationists say. And I'm not talking about you purposely lie about how the creationists show it. Hey, tell them to go look at Institute for Creation Research. Go look up their stuff. That's one of my favorite ones to look up. And so on. But hey, let them make up their own minds. But if you teach only one side, and it's a side that is carefully worded to hide all the other things that are against the theory, and like I said, with the Big Bang right now is what we're talking about. But there's others I'll go into later as we do the videos, such as like I said, when I went through and had physics and so on, they didn't tell me about these others. I was so shocked when I ran across these, because the only one I ever heard of is the speed shift one, the first one. I didn't know there was these other three. So, and that's when I bring up the question, like, why won't you teach the kids or college students these other three? What are you trying to hide if you're not teaching something? And like I said, if anything disagrees with their theory, they don't teach it. So now we're going to go over how about the speed redshift itself, because that's the one they use. All stars and galaxies are redshifted. That's been proven through scientific study, and that, of course, is the problem, because you would have to have some that aren't, and so on. Even the closest stars and galaxies are the least redshifted. They're not the most. And that one, the more I dug into it, what I found is they expected the reverse. The closest ones would be more redshifted, not least redshifted. So it's a reverse of what they were expecting. The light particles, or photons, do slow down. They've proven that several times in the lab, and that would just make sense. If it hits a medium, if it goes through a gas cloud and the gas is thick enough, it will slow it down. Of course, if a planet comes across its path, it's going to stop because it's going to hit the planet. And most likely, the light's just never going to keep going, depending on how long it takes the planet to get out of the way, and so on. So photon light, or light particles, yes, they slow down as they go through a medium. That's been proven in the lab. Light has weight. With weight, light can be affected by the pull of stars as it passes. In other words, the gravitational pull can make if it's going straight and it curves, it can make the light curve from where it was originally going. So if it was coming to Earth, and let's say it passed extremely close to Jupiter, all of a sudden Jupiter's gravity is going to make it do this. And we'll probably never see that light. Now, I'm not saying it'll make it change that much, but you get the idea of what I was talking about. Isaac Asimov, in his book, Asimov's Book of Facts, 1979, page 330, covered that a lot. And I actually have two of his books on atoms and particles. Pretty interesting reading if you're into heavy scientific reading. No one has ever seen a blue shifted stellar light spectrum star. Of course, that ends that section. That one I'm still looking up. As far as I've been able to find, that's true. Nobody's come out and said they saw a blue shift. They've only seen red shifted. In order for kind of the speed shift one to work, you have to have some blue shifted stars, and they don't have any, like I said, that I know of. I'm still looking. But yeah, that's the notes and everything I took from the different books on basically going over the Big Bang. I studied, like I said, from science, New Scientist, textbooks from both sides. That's the notes I took, and that's what I came up with. And a lot of that really goes hand in hand with another kind of a textbook that I was reading a lot of, and that's Science versus Evolution. You can get it. It says $20, but I don't think it was $20. I can't remember where I got that one from, but it has a lot of good information. Just like I said, a lot of this that helped me with and understanding what they were talking about on certain things. Because like I said, even though I'm pretty good when it comes to mathematics and science, there's still some things. It's been so long since I've been to college, I can't remember what it meant. So, but it really helps break stuff down, and like I said, that's where I took a lot of notes from and added to and took away and so on. But it's a really good book for you to use as a reference. So anyway, that's this video on the Big Bang being a big dud, and stay tuned for the next one where we will cover the origin of the Earth and just basically go over that as well. I don't think that will be too long, but we'll see. So until next time, guys, God bless, and may you have a great day and a great week, and just stay happy, and just keep praying for our nation, because there's a lot going on in our nation right now about who should be the proper leader. I know there's always the propaganda, there's the mudslinging that always goes on, and it's got people stressed out. So yeah, just pray for our nation, pray for our leaders, pray for different states that are going through troubles. Pray for your neighbor. if you're watching this and you're a Christian, pray for your atheist neighbor. That maybe they'll start asking you questions. That's how everything starts. They'll see something and they're like, "Hey, can I ask you a question?" Don't run from them. Just talk to them. But if excuse me, but if you talk to them and they ask you a question and you're like, "I don't know," don't lie to cover it up. Just tell them, "I don't know. Let me go do some research and I'll come back to you. Is that okay?" And a lot of them say, "Yeah, that's okay. Go ahead." And majority of the time, that's what they'll do. They'll wait to hear your answer. And then, but if you do that, like I just did, I told you I got a lot of my notes from that book. Tell them that's where you got some notes from, because it was the best explanation you could come up with. And like a lot of questions and so on were a lot of the questions I had, and it had some great um things written underneath them. And I was like, well, that makes a lot of sense. So I left them in my notes and so on. So yeah, if you don't know, don't lie. Refer them to to somebody that might have the answer, or at least knows where to find the answer if you know of somebody. If not, just tell them you'll do some research and you'll get back to them, and just ask them to be patient, because you want to be thorough in your research. You don't want to just come across the first thing. And like I said, I've got that textbook. I've got a bunch of other books, and that one really covers a lot of information. So it's almost 1,000 pages of just information. So anyway, like I said, God bless, guys, and hope you have a great week. And for anybody that's facing these tropical storm systems that are about to come through, may God protect you and your families, and may you be okay and be able to make them through all right. So anyway, God bless, guys, and as always, thank you to the men and women of the U.S. military. And I didn't post a video on with that in mind on the Memorial Day, and I do apologize. I should have, but just thank you to the ones that have served and have gone down range, and the ones that are still serving today or did serve and are still alive. I know Memorial Day was to remember the ones that are passed on now, but I want to say thank you to all of them. So thank you to all the men and women of the U.S. military, and as once again, guys, God bless, and may you always be protected and blessed in your lives.